All right. That way I don't have to reteach it to, and I don't have to record separately. All right, so again, you have the subheading solving compound inequalities involving and, so we have that written. So you notice in purple it says write as two different simple equations. So remember, what we've been doing is considered simple. So just like when we did absolute values, we're going to be slicing and dicing. So we're going to take the first half of this, and we're going to say 4 is less than or equal to x plus 2. So whatever's in that center part is what's getting shared both directions. I'm then going to write my other inequality by using the other half of it and writing x plus 2 is less than or equal to 8. Now if you want to attempt to roll that sign over, so that way it's both written the same way, the same direction, feel free. However, don't get the answer wrong because you forgot to flip the sign when you flipped your numbers. Okay? So now we're going to solve these. How will I solve these? What am I going to do mathematically? Go ahead, Kayla. Good. We're going to subtract 2, and that's going to be on both of these because both of them say plus 2. So in this case, 4 minus 2 is 2. I'm going to bring down my sign. It says x. On this other side, we get x. We get 0, less than or equal to, and then we have 8 minus 2, which is 6. All right. What questions do you have so far? Well, now we got to record our answer. So far, remember, the ultimate goal with inequalities is asking, what are all of the values that x can be to make this true? That is what we're answering. Okay? Is this an and or an or statement? And. So I have 2 options to record my answer. Option 1 is to use the word and. So I can take my 2 responses and I can say x is greater than or equal to 2. Notice I just rolled this over. My sign's mouth has to stay open towards the x. And x has to be less than or equal to 6. I could also, instead of using the word and, I could merge them together just like this first one was written. So I'm going to take these 2 parts and I'm going to smash them together so the x's are on top of each other. So it would say 2 is less than or equal to x, which is less than or equal to 6. Both of these tell the same exact story. So both of these answers are exactly the same, one using the word and the other using the word, or the smashed version. What questions do you have? But we're not done. You have to graph it. Okay? Now with simple equations, I did not worry about the graphing component of it because you had technically already done it in 7th grade. Okay? Sorry, wait, my handy dandy poster that's normally hanging on my wall. This will only give us part of it. All right, we need to remember graphing inequalities, and graphing inequalities has 2 different parts. Actually, I gotta give this part. So let's do this. All right, so this is your quick reminder of inequalities. All right, you have open dot versus closed dot. An open dot is used when you have less than and greater than. A closed dot is used when you have your equal to's. Okay, think about it in kindergarten. If I were to say, put a dot on 3, on the number line, you would have put a dark dot, right? A closed dot means equal to. Open dot says, start here, but I'm not your answer, right? Because the next number would be the answer. So if I was greater than 3, I would start at 3 with an open dot, but 3.1 would be my first number I could use. Okay? The other component then is your shading. All right, you shade left for less. So if it's less than, we shade left. And you shade right for greater than. So less is left, greater is right. Left is less, greater is right. Okay? So again, that's your little cheat sheet. So we're now going to go back to our problem. We have to graph this answer. Okay? Does anybody need more time with us? All right, we get another moment. I guess I have that on the slide. First one. All right, we're good? Okay. I'm going to go back to our problem. All right, so we have our answer. So I need to graph this. So I'm going to go ahead and I'm going to draw myself a number line. I'm going to move this row. All right, so we're going to draw ourselves a number line. On this number line, we have to label our two numbers that are our answers. So I'm going to label 2 and 6. Now I have to decide open dot or closed dot. So is my 2 open dot or closed dot? Closed. So again, I have my equal sign, my equal to, so I'm going to fill in my dot. Is 6 open dot or closed? Closed. All right. Now I have to work on my shading. All right. X is greater than 2. So which direction would I shade? Okay. And X is less than or equal to 6. So what direction would I shade from the 6? Left. So notice I'm shading left from the 6. I'm shading right from the 2. So this would be my graphed answer. So and statements, the color should always come together. The in-betweeny will be colored. It's going to be greater than one and it's going to be less than the other. So I can meet both criteria. Right, what questions do you have? I know that was really long-winded to go through one problem. I promise it is not that long. Okay? All right, so let's take a look at this next equation. All right, so we have -5 is less than or equal to 2x plus 3, which is less than 9. So -5 is less than or equal to 2x plus 3, which is less than 9. All right, what's my first step? Brady, what am I going to do? Slice and dice. All right, first equation is going to say what, Xavier?
-5 is less than 2x.
Don't forget the equal to. Good. 2x.
2x.
Good. Claimer, what is my other equation going to look like? So we just did this. That went that way. So now what is my other equation? Perfect. All right, we got to take that other part. All right. Miss Benjamin, what am I going to do to solve both of these? Good. I'm going to subtract 3 from both sides to start. All right, so I'm left with, Longo, what do I get for the first equation so far? Good. Is right, Mr. Delgado, what am I gonna get for this other question?
2x is greater than 6.
Greater than 6?
Plus.
Good. Ms. Castro, what will I do to solve both of these now? Okay. Ms. Cruz, what do we get for the first equation? Right, x is greater than or equal to 4? Or 4 is less than or equal to x? Is it negative? Good. Did my sign have to flip? No, good, because I divided by 2, so my answer is allowed to be negative. I only flip when I'm actually doing the negative. All right, Brady, what is the answer to my other one?
X is less than 3.
X is less than 3. All right. We're going to graph our answer. So you told me that I'm using negative 4 and that I'm using 3. Please make sure they are in number line order. Don't put 3 to the left and negative 4 to the right. That's silly. Negative 4 is less than 3. Ms. Esper, what am I doing? Open circle or closed for negative 4? Closed. Why do you see that? Good. We have our equal to. Okay. Xavier, we're back to you. Open dot or closed dot for x is less than 3. Okay, we have open dot. Does everybody see why? Okay. So again, it's saying start here, but I'm not your answer. All right. Shading left or shading right for negative 4? It'd be Claimer. Shading left or shading right? Okay. And Miss Benjamin, for 3, are we shading left or are we shading right? So x is less than 3, we're shading right? Left. So again, a way to remember left, less, both start with L's.
I just learned that X is on the left side.
Well, but that's only if the x is on the left side. So that's the dangerous part, because if we would have left our answer down here the other way, we would have said negative 4 is less than or equal to x, and you see that pointing left. As long as you know it's only when x is on the left-hand side that strategy works, yeah. All right, but we would have shaded left, so again, we're dealing with the space in between. All right, what questions do you have? All right, I'm gonna let you handle this one on your own then, or these 2. All right, remember in the classroom, we stand when you're done. All right, so we have negative 9 is less than x minus 10, which is less than negative 5. And we have negative 4 is less than or equal to 3n plus 5, which is less than 7, or less than 11. So again, stand once you got your answer. Then you're slicing, you're dicing, and then declare your final answer in a graph.
May 27th.
Already got 3 in there. Well, you're not splitting, but you also put out 3 and plus 5 was both. Split them up. All right, go ahead and have a seat. Ooh. Just wanted to give you shapes and stuff. Alright, so first thing we should have done is we should have added 10 to everything. Well, yeah, that's what I'm doing with my word. So we would have got 1, X, and 5.
Yeah.
So we should have had 1, 5, open dot, shading together.
Nice.
Well, so in teacher land, I'm also supposed to teach you the really long way to do work and then show you the really easy way, so you have a appreciation for this and you actually know where the numbers are coming from. Alright, so here we should have subtracted 5 from both sides. So we get negative 9 less than or equal to 3n is less than 6. I then need to divide everything by 3. So we get negative 3 less than or equal to n less than 2. The only thing you have to be careful with in this step, if you were to do this, is if this would have been negative. If that's a negative, both of these would have had to go to the other side. My computer totally just walked out. Alright? So in graphing this, we should have had a closed dot for negative 3. We should have had an open dot for 2 and shaded in between. What questions do you have?
What happens if we're on another line? Is this is a far side? This is right. We're doing it.
But they're both shading left? We'll get to that. Welcome to math. Alright, so that was all about the and statement. Now let's talk about or. So again, you don't have to write this. This is just showing you. With or statements, they're going to go the opposite directions from each other. Alright, x has to be less than 0, so we would shade left. X has to be greater than 10, we would shade right. You put those two together, you're going to see them in opposite. The reason why it is an or statement is I can't be less than 0 and greater than 10 in the next sequence. There is no number that exists. So that is why these are or statements. Remember, or statements, can be either one. Okay? So go ahead and put this mini heading again. If you need to put a highlighter or a circle around it so you know, if you're starting a page, whatever the case may be. So we're now going to solve compound inequalities involving or. Involving the or. All right. So in this one, it says negative 4 plus a has to be greater than 1, or negative 4 plus a has to be less than negative 3. Now, please understand, while I know they both have this negative 4 plus a in common, I am not allowed to write it like that. Understand, if I write it like this, I am implying and. And when I imply and, it means both have to be true. And once we get to our answers, there's no way I'm going to be able to be greater than this number and less than this number at the same time. So understand, again, this cannot be used for or statements. All right, so strategy is still the same. Okay, slice, dice, and solve. So how am I going to solve these? What will I do mathematically, Brady?
Add 4, negative 4.
Am I adding negative?
Positive 4.
Okay, so I'm adding 4 to both sides. Okay, so I'm going to say plus 4 equals plus 4 equals. So I'm left with a is greater than 5. And I'm left with a is less than 1. Okay? The biggest thing with our answer, we have to then make sure we are writing the word or in between them. No word implies and. So and is like the default answer. We have to tell it that it's or. All right, let's graph it. What numbers am I using?
5 and 1.
5 and 1. Is that correct?
No.
No.
Okay.
Bigger than 1.
You have to pay attention to this. All right. I cannot write my number line like that. You need to write the 1 is smaller than the 5. Open dots or closed dots? Open. Notice I'm drawing the dots through my number line. They're not floating above it. It's like if I had my number line and I numbered it and I said, plot a point at 3. You would plot the point at 3. That's what we're doing. We're putting the dot on the number line. All right? For my 1, am I shading left or am I shading right? Okay, so again, it says A is less than 1, less than left. For the 5, left or right? Right, so A is greater than 5. There would be my draft answer. Definite maybe? Sarah's mud? Do another one? Practice makes perfect. All right, so in this scenario, 2x is less than or equal to 6, or 3x is less than 12. So I need a value that will satisfy one or the other. All right, what am I going to do on the left equation? Kayla, what are you going to do? I'm going to divide both sides by 2. So x is going to be less than or equal to 3. Or, what am I going to do on that right equation? So, Yeja, what am I going to do on that right equation? Divide by 3. So x is going to be less than 4. Make my number line. What numbers am I putting in? 3 and 4. Open dot or closed dot on the 3? Open dot or closed dot on the 4? Shading left or right for the 3? Less than left. It makes an arrow for me. All right. 4, am I shading left or right?
Less than 4, yeah.
Is that allowed?
Yeah, can you go over it? Yeah.
He's left side.
Would you like to see the poster, please?
I am the teacher here.
Would you like to see the poster, please?
Are we gonna do what?
My question is, what's the answer? Is that the answer? Is there a more correct answer?
That is the answer.
I think
What's the answer?
that.
The whole thing?
Yeah.
That's your
Give me a number that makes this true.
3.5.
You said no. Yeah, with math done, I don't know what no. Did you say no? You told her no? You said no with the 3.5.
No.
You did? The 3.5 won't work? Which one won't it work for?
Oh.
But does that matter with an or statement? I like your thought though. If this was an and statement, that green segment that you can see would not work. But because it's an or statement, however, there is a better declaration of an answer. What's the better declaration of an answer? Is there? I think Let's check. X is less than or equal to 3, or X is less than 4. I have that double.
Hold on, I got one. I got a
All right, I'm ready for your suggestion.
You don't draw those first. You just keep it there because it's equal to.
So you're saying I don't have the X is less than or equal to 3. I only put X is less than 4. All right, Jayla, your suggestion?
This is the only one we have to combine them with like X is greater than or equal to X less than.
But again, the moment I smammage them, that means and. And if I pick 3.5, like Alexa said, that's not going to work for one of them. So it has to stay an or state. Okay? Equal to? But 4 won't work. Because if I plug 4 in there, 3 times 4 is 12, and 12 is not less than 12. 12 is equal to 12. Okay, so I like Brady's suggestion, but is it allowed? So he's saying I can declare my answer as just X is less than 4. Does that work for both of them?
Yeah,
Oh, wait, I don't know.
3 is less
But 3.5 is also less than 4.
Yes, it does work. Because it's equal to 3 times 3.
But what about 3.5 or 3.75 or 3.99999999999999999?
Wait, it still does. It is still less than 3.
But I need to be less than 6. So am I allowed to record my answer as X is less than 4 without having that or statement listed?
Maybe not.
Hey,
why do you have to grab it? No, we gotta grab it.
So you just want to leave it with the overlapment and record our answer like that? Okay.
Really? Really? That's what all you have to do?
Because it's and this is why I'm having this conversation with you. If this was an and statement, Brady's suggestion is exactly what we would do. Because it would make both of them true if it was and. Because this is an or statement, and this section does not satisfy both of them, I have to still tell the listener, the reader, the whoever, that it's still either or. And if I only record that, that implies and then I'm wrong. Okay? So long story short, really long story short, this is our final answer.
What are you guys thinking?
You can hit big bucks for that. Alright, what questions do you have? Besides brain exploded, yes.
Why do we have to graph it?
We graph for the purpose of visualizing the numbers because there's numbers that exist between whole numbers. So fractions, decimals, everything in between. So that way you understand, especially here, what numbers are between 3 and 4. Well, they're all decimal values, right? 3.1, 3.2, 3.3, 3.4, 8, 6, 5, 12. Right? Yes.
So you just open that.
Yep. And really the answer is, it's any number less than 4 because it's an or statement. Either one, my answer will work. But I have to have that or declared. Alright, your turn. Ooh, that's really ugly handwriting.
Looks like I do.
Yes. Alright, so for C, it says 2 plus R is less than 12, or R plus 5 is greater than 19. And then D says 7x is greater than or equal to 21, or 2x is less than negative 2. Alright, stand when y'all done. And stand when you're done.
Okay, Emily.
You can only see my screen, but yes, she can hear you.
Yeah. Oh.
She can have some
Where do you go? Yeah, we got her.
I wouldn't give this out loud because it's look at it, my blood off. Thank you.
Alright, glad to have a seat. Alright, so this first one we should have subtracted 2. So R is less than 10. Alright, here I should have subtracted 5. So R is greater than 14. Open dot or closed dots?
Open, good.
Open for both. So again, remember open says, start here, but I'm really not your answer. Okay, so 14, while it says start here, 14 plus 5 is 19. 19 is not greater than 19, but 14.1 will be. So it says start here, but it really, your answer starts after it. All right, taking a look at this other one. Divide by 7, divide by 7, so x is greater than or equal to 3. Oop, what? Can't forget the or. Forget the or, it implies and. So x is less than -1. Double check on your number line that -1 is to your left and 3 is to your right. Open dot or closed dot for -1. Open dot or closed dot for 3. Then again, we're less than -1 and we're greater than 3. What questions do you have?
No.
For many of you, it's just the details. You've got the math side of it down. Now we got to focus on the shading, or we need to focus on declaration of our answers. All right. What else do I got for you? Anything? Ooh, these ones are fun. All right. Just write the heading. So again, it's a little subheading. Writing a compound inequality from graph. Really should be from a graph, but you know. You do not need to write these 2 steps. However, this is what we are going to be doing. If you want to write them down to remind yourself, feel free. We're going to write each of the simple inequality, and then we're going to decide if it's and or. And I'm really not going to do it in that order, but we're just going to practice these real quick. All right. First question, and or? Brady, what do you think?
Or.
Xavier, what do you think?
Or.
Kenyon, what do you think?
Or.
Longo, what do you think? Lamer, what do you think? Benjamin, what do you think? Jayla, what do you think? Neasia, what do you think? Alexa, what do you think? Anna, what do you think? She's not going to answer. Maybe she'll answer at home.
Put it as a question on the X button.
I'm glad you guys have already learned that by now. Those of you saying or, why? Jayla, why are you saying or?
Because all the aliens just
Good. Okay. The and statements would be coming at each other. The or statements are always going away from each other. So in this case, we would have it as an or statement. So I'm going to write or right in that empty space just because it's easier for me to see.
You want to write it?
Yes, please. You should have this graph at least.
Oh.
You don't have to write the words, but at least have an example for yourself. So because it's an or statement, I'm going to leave them split. So now I have to write a simple inequality for this. All right, so I'm going to put x and x. So x represents this space. So now I need an inequality symbol. So x is going to be what on this left side? Xavier, what do you think? Just left side? And y equal to? Because it's closed dot. So your sign is determined by the dot. And then the shading direction. And then what's going to be my number? -1. We're going to just steal the number. All right, on the right, x is, what is my inequality symbol? And why do you say equal to? Close dot. And what number are we using? 7. So this is the graph of a compound inequality that is x is less than or equal to -1 or x is greater than or equal to 7. All right. And or? Okay, it's an and statement because they are coming together. Now you can make your decision like this. Me, did you notice here how I put my X above the color? I can do the same thing here with the green. So I'm going to put X in the middle of it. Now I'm going to pick my sign. So I have my number 0 on the left. And I have my number 6 on the right. So again, all I did was steal from the number line. I stole the color is 0. I have my 0. I'm sorry, color is X. I have my 0 and I have my 6. Now we have to determine the signs. What is the sign between the 0 and the X? Brady?
Greater than or equal to?
Okay, so is the greater, what direction?
It's Something like this. I will do that.
So the x is the greater than or equal to? Okay, so 0 is less than x. Well, that's true. 0 is more to the left than the colored part. All right, and then what about the other one? Maja, what do you think? Just less than? Why? Because they don't got. All right. What questions do you have? All right, let me stop the recording real quick.